let me start with a short presentation, really just a few slides. Basically, my point over here is to show two things. First one is the app platform itself. So the beginning will be mostly about the platform, how you can use it, what we have in the platform to some extent. But my main point is around the cloud-native observability stack based on open source projects. This is a theme that we discussed with Timo, and we would like to move forward and maybe make it like, let's say, a selling point of the application platform. But that's actually a set of projects, not a single one. So this requires a lot of effort. And this is also related to the series of blog entries I did, and I'm still doing, actually. Okay, so just a few assumptions, then I will tell you about the customers app that we're going to use, like the simulated customers app that we're going to use for this demo, and what is included in the observability stack, actually. So first assumption, this demo is ran from a point of view of a customer. So the assumptions are that we have a potential customer that has its own custom app that he or she wants to observe using open source tools. So this is an important part, the open source tools. So, well, companies that are trying to not get locked down by a single vendor and they want to stick to open source solutions, because there are many observability related projects right now in the market, but most of them are actually commercial. Second thing is that obviously the customer doesn't want to run this observability stack on its own and would like to use something pre-configured, something opinionated, something that he or she doesn't have to care about. It's for us to use our tools to deploy what customer needs. And like I said, the important assumption as well, this is a technology preview. So what's the app we're gonna check and we're gonna like run our use case with? It's a simple microservices architecture oriented app that has 3 services. The first one is an HTTP API server that basically does routing to next microservices as needed based on requests received. Then we have another service that is called To-Do Manager in blue on the picture over here, that actually does the management of to-do entries, because what the app does is a really simple to-do list management. And then we have a storage backend, which is a single MySQL instance where we actually keep all the data. The customer has the app ready, but because it is like composed of multiple services, Helm is used to deploy actually the application into the cluster. That's how the application looks like. Now, here comes the observability part. In general, observability is a term used for data that comes from 3 major sources. So one of them is logs, another one is metrics, and another one are traces that the application produces. And then these are only data sources. So to actually make something useful out of them, you need tools that will allow you to analyze, visualize, correlate the data, because they all describe your app and events happening in your app just from a different angle. One of the important properties here is that quite a lot of those tools, they can work without ever changing your code. So this is an important property, that to make use of, for example, like logging or metrics, or to some extent also traces, the basic level you can frequently get for free. For free, I mean without changing your source code, which can be a challenge for some organizations. But obviously, if you decide to integrate your code closer, you will get some additional benefits. So here it is with the observability stack. So we again have our app.
Brief comment.
Yeah?
Henning chatted if you could explain the difference between logs, metrics, and traces. Maybe it will come up.
Sure. Sorry, I think you're okay. I will stop sharing, not stop sharing. I will exit full screen, because like I said, I lost you, and yeah. So logs, simple. Basically text messages that are outputted to standard output or files on Drive, right? Metrics, These are mostly performance related, so performance metrics. Stuff like how many requests we produce, how many requests were successful, what is the current, I don't know, synchronization loop length, things like that. And traces, the last source, and also the least popular one. It's a clever idea. It's a clever idea invented for microservices, where every part of the microservices application, so every microservice, does basically something like that. When the request comes to the application, it has a unique ID. This unique ID is then used by a single microservice to report to a central server that that specific request with this specific ID arrived at this specific microservice. If we can identify the request, so really each request has a unique ID, and then each app reports the status when the request arrives and when it leaves the system to a central server, then in the central server, we can see a global image across all the services of when and how the request actually traversed our microservices graph. So you can immediately see that, like, assuming that, for example, it took 1 second to process your request, you can see that like half of this time was spent in one microservice, while the other half was spent in 5 other microservices. So if you're trying to trace a bottleneck, maybe it's worth checking first the first one. I hope it's okay for now. I will show you a demo where I will show traces, and I think it will be much easier to get the concept from there using a real example, okay? Okay, so let me get back to my big picture. Okay, but now it won't be readable. Okay, switching to presentation mode again for a second. Not yet. So we have the to-do namespace, and over there's an app that we as a customer want to run in our cluster. Now, all the other services are related to observability. Going from left to right in the tracing namespace, we have the tracing setup. Basically, this is a longer story. I don't want to go deep over here, but there are 2 projects, Jaeger and Zipkin, that are those services collecting traces. Over here, we will use Jaeger, but to deploy Jaeger, we use Jaeger operator because it's really nice and easy, especially for demo setups and development time services. It is really easy to create a Jaeger deployment. And before we use Jaeger, we will use one more component, which is called Open Census Collector, which is like a proxy intermediary between all the other services and Jaeger. One of the very useful properties it has, it knows many tracing protocols, so to say, and it can do live translation. So when we use Open Census Collector, we are not really locking ourselves in, let's say, Jaeger's tracing protocol. We can easily switch to an alternative like Zipkin. So that's the tracing setup. In the orange in the middle, we have the Linkerd setup, which has some friends which are not really related to Linkerd, but deployed together actually in the setup that I'm going to use. Linkerd is a simple mesh. I think that right now we have 2 major projects in open source service meshes, which are Istio and Linkerd. I'm using Linkerd over here. Which one is better is a completely separate discussion, I think. But basically, the important thing is that Linkerd works by injecting a proxy in front of every container that is being run in the pod. So we have API server pods, Linkerd injects a proxy there. We have to-do manager pod, Linkerd injects a proxy there as well. And all of those proxies, they can take part in the tracing effort, and they can forward automatically information about traces to the Open Census Collector. So that's how we can get some tracing basically for free just by providing Linkerd proxy containers that are part of Linkerd mesh deployment. Additionally, Linkerd provides security here because in my application, there's no security. The developers haven't thought about it at all. But Linkerd does automatic mutual TLS, point-to-point encryption for all the services with cryptographically signed identities. So it's, again, something we can get as part of this service. Then we have our well-known friend, Prometheus, for collecting metrics, Grafana for visualizing everything. And then we move to Loki. Loki is a new kid on the block in the log collecting space. It's not that new, actually, anymore. It is definitely more than 1 year since the first stable release. The reason why I'm using Loki here is because it is way lighter than the EFK stack. So it is really way lighter, and it's also way better integrated with Grafana. So I don't need to run heavy Java applications like Kibana and so on to basically see my logs and then be able to search them. Again, I will show this in a live demo. This one component I skipped, Nginx Ingress Controller, which is also our well-known app, forwards our request to the API server of the application. And also, Nginx Ingress Controller can take part in the tracing effort. Actually, it will be a critical component in this regard over here, because someone needs to start the identification of incoming requests. And in my demo, this will be Nginx IC. Okay, that's
Can I
it.
have a quick question on the diagram? This is just curiosity on a detail. Why
Sure.
Why do you have Prometheus and Linkerd deployed together? Is there a reason for that, or is it just easier? Or
yes, the reason is it's easier. I mean, okay. Linkerd actually provides some functionalities by default, and it doesn't reinvent the wheel. So actually, Linkerd uses Prometheus as its metric storage, Grafana as the visualization engine, and so on. So if I deploy Linkerd, I get them by default.
But having Prometheus in a separate namespace is fine. There's no sort of reason for it to be in the same namespace.
Yeah. Sure. I mean, if we want something complex, we can always disjoin them and deploy wherever we want. For demo, it is the easiest way for me.
Fine. Cool.
Okay. So I have created a cluster for this demo. All I did is to deploy Nginx Ingress Controller app there already. And now it's time to deploy our stack for observability. So this is the how to use the platform, how customers can use the platform. So if I'm the potential customer and I want the observability stack, in the future, we would like to probably make the whole stack like an opinionated single-click deployment group of applications, something like that. But so far, we need to deploy the apps one by one. So let's start with Loki. And deploying an app can be as simple as giving a name to the app, Loki, and given the namespace. The namespace will be created if it doesn't exist, and clicking install. So that will already deploy my Loki app. It can be a little bit more elastic if you need so. For example, we're going to deploy another piece of our observability stack, which is Open Census Collector. No, let's start with Jaeger operator. Okay, Jaeger operator. We need to, I want to place it, I want to name the app Jaeger operator. We can choose from different versions. So if there are multiple supported versions, we can choose the chart version. In this example, I want to use a version that is older than the most recent one because my app is compatible with this version. And I want to deploy it into a custom namespace, which I call tracing. And that's it. Let's deploy it. And while we do that, we can already check if the applications are really moved into our cluster. So we have Nginx Ingress, we have Loki, Jaeger operator is there as well. So yeah, if we check the operator, it's already running. Meanwhile, we can deploy next apps. We'll have to wait for a minute or two before everything starts, so images are pulled, things are started, and so on. Right now, let's continue and deploy Open Census Collector. Again, I can choose versions, I can change the namespace, but what is important, I can also provide configuration files. So for example, for Open Census Collector to work, I need to let it know where is the Jaeger server that Open Census Collector needs to forward metrics to. So I have a ready config file, I can choose it, and again, deploy the app. And now is a good moment for questions or discussion in general, because we need to wait for a second before everything gets installed and we can progress with Linkerd installation. So if you want to ask anything, we need to wait now a minute anyway.
I can't install Linkerd yet.
I can't install Linkerd yet because there is a race condition, because Linkerd needs to do stuff on namespaces, needs to annotate them, and other tools, as they install, they annotate the namespace as well. So yes, like I said, this is a demo quality not proof of concept, I think it's like a technology preview, what we can do, but yeah, there are a lot of rough edges still. Okay. It seems we can move on. Those things are already installed. Let's install Linkerd. Linkerd goes to the Linkerd namespace, and I need a config file for it as well. Okay. Yes, we will have to wait again, like a minute before everything gets deployed, and then we can move on.
So if we would develop like automation to set up the whole observability stack, then it would automatically run through that list and wait and ping just to see if everything's up to then install the next one, or?
Yeah, we have an idea for a concept that we call upsets, or something like up bundles, where yes, we group apps together so that you can find like an observability giant swarm observability stack and deploy it with a single click.
Could you pull for if it has been pulled up? Is that something that?
What do you mean?
Like, that we actually to find out if something has been installed, is that, can you actually have a service that just reports back when it's installed?
Basically, Hapa will report this status back over here. So, for example, if we check here, the status is deployed, but the truth is that this feedback of application status to the client, isn't it, could be better. We discussed this today and yesterday with Oli. We have some ideas again about how to improve it. I'm checking from the CLI because that's the fastest way to get the feedback, actually. So we don't want to wait for nothing in the demo, right? But in general, yes, you can check the status of deployment in Hapa already, and we want to make it better.
Okay. And the YAML files is something you always have to do manually, or is that also eventually, does it make any sense at all to not create it or do it like through the user interface? Would
you mean configuration YAML files?
Yeah, exactly.
So those YAML files are, let's say, use case specific. So the customer makes decision, I would say. For example, my Linkerd config file, it's that short. I'm just changing the way encryption will be provided, certificates will be provided, and I'm changing the default and more secure read-only Grafana role into less secure but more elastic admin role, which I will need in this demo. But again, this config is up to the customer, basically.
And the customer,
specific to this deployment. Yeah.
all of them probably will know how to do the config files, or are there like recommendations or examples so they can just follow them?
Our general approach is that if only possible, those configuration files should be optional. So we have a rule that if it is only possible, we're trying to provide send defaults. Those options that I, for example, changed over here, they are changes from rather safer defaults into less secure defaults, but more elastic ones. At least the second one, okay? So we're trying to make them sane by default. So as you've seen, I deployed like 4 or 5 apps, but used a config file only for 2 of them. But, well, sometimes you just need them to tune everything to your liking. Okay, so the observability stack should be ready. We now, as a customer, we have a cluster, we have the tooling, we can deploy our application. So, yeah, as I said, the customer's application, the to-do app, is maintained and deployed with Helm as well. So let's try to do this. Obviously, if the customer only would like to do so, this can be brought like one step further and turned into our app. So app that can be placed in a catalog, and then this catalog can be registered into the cluster, and customer could deploy this app from Hapa or, well, any other API client that can create app CRs. But over here, like I've showed this path already. So over here, I'm using Helm directly. That's possible as well. And the application should be deploying. Okay, it is. We just need for the images to be pulled. So again, a second, and we should be good to go.
You're stressing it out.
No, just waiting. You know how it is. You need to wait before things break. It's been like at least 15 minutes of demo and nothing actually failed yet. So, okay. The app is deployed. This should be running now. Yep. So now we have both parts. We have, well, 3 parts. We had a cluster delivered by Giant Swarm. We have the observability platform, also delivered by the Giant Swarm team. And now we have our own app, the thing that brings money to the customer, deployed on top. So let's use the app. To use it, I need to check the ingress address. Just to not make it that long, I will save it as a variable. And now, okay, I don't have any real API client for this demo app, so I'm using curl to talk to the API. So basically, I will be sending raw HTTP requests to my app. This request just creates a new entry on a to-do list that has this text as a to-do entry. So let's post it. It was created. It got some ID from the database. It's not done, not marked as done, and the text is over here. Now we can fetch the text. And let me do this in a loop. So what this loop does is it is fetching all my to-dos on the to-do list in the app over and over again, okay? Okay, as you can see, we have some hiccups. In general, my requests work fine, but sometimes they take a long time to complete, and they complete. And sometimes apparently they fail for no real reason, okay? So probably that's why my investment in the observability stack should pay off, and I should be able to actually learn something about why my requests are misbehaving. So I need access to, let's start with Linkerd. Okay. I moved my browser window to another screen. Is the sharing still working? So I can see.
Perfect.
Cool. Okay. So this is what we get like for free from Linkerd. Because it injects the proxies everywhere and the proxies trace all the requests that are passing through it, we can already see something. What we can see is that in the to-do namespace, we have non-perfect success rate. So it is high, but not 100%. We have around 5 requests per second, but interesting thing as well, P50, so 15th percentile, half of the distribution of the latency is very low, like 2 or 4 milliseconds. P95, so the 95th part, like in 100 part of the distribution is low, jumping to very high seconds. And P99 is really high, like a few seconds. So there's a big difference in latency distribution between half of the distribution and the end of the distribution. When we go to the namespace, we can see how it looks like divided, grouped by deployments. So we can see the failures probably come from the API server service, because that's the one that doesn't have a 100% success rate. To-do manager has, but latency, hard to say, because both of them are registering these high latency values over here. We can check if it will, these are current values. We can go to Grafana and check if they were always like that. So the request rate, it is more or less constant, around 4 RPS, but the success rate is really around 90% now. And as you can see, this is the latency distribution. Latency, again, P50 is low all the time. P95, P99 are jumping up to 4 seconds, definitely above 3 seconds, but only sometimes. So there's definitely something going wrong with latency over here. What else we can do to investigate this situation using the tools that we have? So next thing we should check are logs.
Can I just ask a short question?
Sure.
Why wouldn't I start off with Grafana? Because I don't know where to look.
Because Grafana shows you metrics. Metrics basically show you a graphical representation of your current and past situation in the system. They can be, or, well, they might be conclusive. It's not that they will definitely tell me what's going wrong. Over here, I know there's something wrong, because this distribution is a strong hint that something's wrong, that my latency, my response time varies a lot. If there's a difference between 4 milliseconds and 4 seconds, that's like 1,000 times difference, right?
Yeah.
It's rather unexpected.
But you basically use Linkerd to locate where you want to look at the graphs, right?
Over here, I used Linkerd's, yes, service mesh capabilities to get this part of investigation, let's say, for free. For free, I mean only with information that was provided by Linkerd proxies. Okay, so let me add a loki.
For free means no additional apps. It doesn't mean for free in terms of traffic or things like that.
For
right?
free, I mean without changing code of my application. Because from customer's perspective, probably the biggest investment into the observability system is actually changing the source code of application that the customer wants to monitor. If
That's
I don't have to do this,
message. Yeah.
if I if I don't have to do this and I can already improve my observability, that's probably a lot of value.
Thanks for spelling that out. Thanks.
Lukasz,
So
the data
yeah.
we saw in Grafana was also, the metrics were coming from Linkerd, right?
All of these metrics that I showed in Grafana are coming from Linkerd directly. Yes, from Linkerd proxies. Okay, next step. Let's try some logs. So I have added Loki as a source of information over here. And let's see. We can check for all the logs that come from the to-do namespace. Okay, we have something, but it's a mess. Now,
And these logs come for quote-unquote free as well?
Yes, basically they are raw logs. That's, yeah, okay, that's a very good question. Yes, that's why they are so messy. As you can see, it's hard to find them because these entries, they are composed of only two parts, a timestamp and the log message, which as you can see is rather long, a JSON, and not really readable, okay? That's why...
These are now from the app, right? These are not from Linkerd, just for others to understand.
Actually, over here, they come from both. So from any container running in the to-do namespace. I can do something else. Just let me find a better key to do so. No, not here, job instance. Wait, I've lost my...
It's okay, we can stay here.
Okay, let me get back to that later, okay? Because I wanted to show you one more thing. And that's actual endpoint I wanted to show. Loki works very, very similar to Prometheus. That's for the technical guys out here. So it is all based on labels. Over here, I can filter it further down using different labels that were understood by Loki. So, for example, there's a plugin that can parse this JSON and turn all the keys into labels and all the values into key values. And then I could, for example, filter by HTTP method, protocol, HTTP client, and so on. But to do that, I need to configure Loki to parse my application-specific log messages, because, well, only me as the app developer, I know what is the actual structure of the log. I don't want to do this right now, but if time permits, I will get back to this and do this at the end of the demo, okay? Right now, let's try to, I want to do something else.
But we were trying to find why the app was erroring, right?
Yes, exactly. That was my point. I was trying to find out why my application returns errors. Okay. This is a little bit more specific, but the problem is that now I have a lot of messages over here because this includes logs from Linkerd proxies as well. So, okay. Logs are important. If I knew what I'm looking for and I knew my app better, I would probably type a query here. Like, for example, we want to search for any string that contains text error. Okay, sorry, my log.tql is not up to speed yet. This should work, I think, but it didn't. It should. Okay. And nevertheless, I can tell you, because I wrote this app, that logs are useless in this case. So even if we find the logs, they are very scarce, and we won't find a hint about what's going on with Loki and logs. So we know there's something wrong. We still have this third data source, which is traces. So let me just set up a port forwarding for Jaeger. And we can check this again. By the way, this is Grafana 6 point something. I'm not sure which one exactly. In Grafana 7.1 or 7.0 up, you can see traces directly in Grafana. So there's no need to switch to another UI. They work exactly the same, just they are integrated in a single application, and you don't have to switch to see that. Okay, so here we have Jaeger. Sure. And we want to find some traces, some recent traces. Okay, that's good, but not perfect. Let me do one thing. I forgot to restart the services to register with Open Census Collector. Proxies, Linkerd proxies, they are not restarted by default. So if there was no Open Census Collector, they haven't connected. I need to restart. I need to restart this guy. And this one. And once they're up, I will issue just a few requests to not have so many traces to choose from. But I think some pattern will show up. Yep, traces are now being updated. And for example, we can have a look over here. This is a full trace of more or less full trace. Sometimes some minor parts are delayed before they reach the server. But this is a trace that shows where the time was spent when servicing our request. So as you can see, there are many components. Linkerd is showing up over here as well, To-Do Manager as well, and Nginx as well. But the lowest layer is over here in the API server. And all we have learned so far is that the list to-dos operation was taking really long. This is forwarded to To-Do Manager. And actually, there's an information that it was the database. The almost whole time of this request, so over 2 seconds, was spent in the database when doing DB list from the database. So it seems sometimes we have a problem with our database. So when we look at the distribution of those dots over here, they show here's real time, and here's how long the request took. If we click this request specifically, they are like all the missing partial traces are combined now. They arrived at the server. As you can see, the request took over 1 second in this specific case, and almost all of this time, except of 100 milliseconds over here, was used by the database. So that's why we probably didn't find anything useful in my log entries, because they are not that good as well, but mainly because it was the database that was responding so long. So now the investment is starting to pay off. We know our problem is in the DB, and we need to do something about our database. But this request was actually completed successfully. We had another case where they weren't. As you can see, this trace is completely different from the previous one. Over there, we had all the time spent in the database. And right now, the database is 1.2 milliseconds, close to nothing. And the actual delay is caused by also API server, especially when accessing v1 to-do URL, and then forwarding it to the To-Do Manager list to-dos operation, but between one and the other. So list to-dos forwarding is already fast, but something took time before processing this URL, v1 to-do, and forwarding the actual request to another microservice. So We are probably not golden. We haven't pinpointed a specific line in code that is causing those issues, but we are close. We have 2 traces that were very conclusive and that are showing us where to look next. And these were the 3 data sources I wanted to show you, and the demo app setup that I wanted to share and use as an example for this stack. That's it. I will happily answer your questions now. We can also try to reconfigure Linkerd to get log parsing in place meanwhile.
Just my curiosity, you said you were starting spans like from the Nginx Ingress controller?
Yep.
Just because I don't know how this works. If the IC starts a span and then the application also expects to start a span, do you have to like coordinate that correctly, or does it kind of do the right thing there?
Basically, you don't, because you have language-dependent libraries for everything you can think about. So you don't handle this manually. You have middlewares, you have libraries that does that for you.
Okay, and they're smart enough to know if they need to start a span or not. Okay, cool. I didn't know that.
No, actually, because if you want to start the span, you need to do this explicitly. If you want to start, that's a trace. Span is just this single entry,
Sorry, trace,
like between
span.
this and one. Yeah, but that's not really important. Important here is that my app actually already expects this trace ID to be there, and it is injected by Nginx. But obviously, you can configure this differently.
But you can do that either way. You can either have the application start the trace.
Yeah, you can start this at the application level, but obviously from admin's point of view,
from the IC, it's easier.
yeah, including Nginx is IC, the Ingress controller, is really important because it gives you observability from the very edge of your system.
But
Actually,
does that start spans for traces for every request, or like only requests for those services?
Great question. Normally, you obviously don't want to do this for every request because your system will die from overload and instantaneously. But because this was a demo, and I don't want to have just like 1 in 100 requests because I won't have anything interesting to show you, I forcefully configured this to collect all the traces there are.
No, sorry, not the number of traces you're saving. Like, if you configure the Ingress controller, like, can you configure the Ingress controller to start traces like only for one service, or do you have to sort of configure it for all services? So, like in a situation where you'd have one service on a cluster that started traces and one that didn't.
I don't know.
Okay,
you can
fine.
definitely control the probability of tracing headers being injected. So it can, like, even Nginx IC can do the sampling and only inject headers in some of them.
Do that by the actual URL as well. Yeah, sure, with you.
Yeah, but I haven't checked if it is possible to do this, for example, based on, I don't know, other headers, URL, stuff like that.
Just curious. Cool. This was fun.
Yeah, I think it is really useful. To be honest, like, that's the open source version. If you check like what Datadog has, for example, or I don't know whose demo I've seen as well. Yeah, they already have this data sources better correlated, actually. But for the open source, it is the current status, I think, and it's not bad. I mean, this can be really useful already.
I think exemplars with the sort of open sensor stuff is going to help, but we're not. Oh, actually, this is the other question. So you actually have tracing support built into the application, right? So I guess
I actually do, yes.
If we're doing this for an app that doesn't have it, it's just the sort of intra-service times,
yeah,
right?
Without app support, we would get only from Nginx and from Linkerd proxy. That's it.
But you would still see the problem here, right? That the database time is actually a problem. So I think that's pretty helpful.
Not really, because you would only see up to this level. So you would know that the problem is related to the least to-dos operation, because that's the URL that was traced by Linkerd proxy, but nothing below that. So I wouldn't know if that's in the service, in the database, or something like that.
Sure. Why don't you get the request between to-do and MySQL? Because
Good question.
MySQL expose traces or something.
Because MySQL doesn't talk HTTP nor gRPC.
Because Linkerd only does HTTP or GFC. Cool, sweet, with you.
Because all of this stuff, all this thing is based on injecting HTTP headers.
Or gRPC metadata, right? Sure.
gRPC is actually underneath HTTP as well. This HTTP-like, okay, HTTP-like, but yeah.
Sure. Cool.
Okay, so to sum up, that's how we basically see the observability stack. It's not set in stone. I mean, all of the components and the way it should work and so on. But having the complete setup, the whole, the stack where you can see all of the data sources coming, metrics, logs, and traces, can be really valuable.
Question from my side is, so basically every developer who develops an app needs to have some monitoring and observability, otherwise they don't know and understand what goes wrong, correct?
Sure.
So, and then this would be kind of an open source stack that we would offer to them. What would be the alternative? Would they just run next to an open source stack, whatever, in kind of a monitoring solution like Instana or something else? So how does that look like? What is the alternative for the developer?
I'm not sure what you mean by the developer, because there are like two aspects. First one is really like literally the developer of the app. So libraries you need to use and integrate with your source code, for example, to get better tracing, to get better metrics, stuff like that. And that is, I don't know. I mean, I haven't used ever libraries coming from like Instana or like Datadog or whatever. But I think they need to be similar in general. I mean, open source libraries are really good. You already have libraries for all the major languages. You have a lot of support projects. Like, for example, over here, my first service is using Go and the standard Go HTTP handler thing. And there's already a middleware for that. So all I did is actually get a Go middleware injected into my configuration, done. For basic handling, that was enough. Now, if you meant from more like developers in sense, infrastructure developer or operators, then alternatives are mostly commercial and they are more integrated. So over here, we're bringing different pieces that do different things and build a stack out of it. When you go with something like Datadog, you basically get this as a package where you choose your options, and that's it. Yeah, I'm not sure if I answered your question, if this was the point.
Yeah.
Follow-on question is, if they already need tracing and observability, then they obviously have something there. What's the cost of swapping? Or what would be the incentive to swap?
Not necessarily. Like, for example, traces are rather a new idea because they came into daylight when stuff switched to microservices architecture, and the problem of tracing a single request through the microservices graph became a problem. It wasn't such a big problem before. So one of the first implementations for tracing were done by Uber and by Google, I think, because they have those huge dependency graphs of microservices that they couldn't debug anymore without something like that. So, for example, we had a call 2 weeks ago, I think, and they are starting from scratch. I mean, they want to include tracing into an app that they are running already, which right now only has logs and metrics. So it's not like you need to build all three of them at the same time. You need to do this. You can do this in stages. Now, to answer your actual question, the cost of swapping one for the other, hard to tell. With open source, it's better because, okay, that's a little bit longer story, but trying to make it short, there were two ideas. One from Uber and one called Open Tracing. and one from Google called Open Census. And they were basically doing the same thing. And about a year and a half ago, instead of competing with each other, they announced a great merge, and they created together a new project based on best practices of both of the others that is called Open Telemetry. I'm confusing these names all over, but yeah, Open Telemetry. I'm not using Open Telemetry over here yet, just because main things are already done and working, but I needed some libraries that are not that popular, but were making my life much easier and preparation time much shorter, and they were still available only for Open Census. So over here, I'm basing on Open Census, although the wise thing to do is to already switch to Open Telemetry if you can, because that's the future. Both of the old projects are getting abandoned in favor of Open Telemetry. And answering now your question, finally, if you're staying with open source solutions, so you want to switch Jaeger for Zipkin, you want to switch one tracing library for another, as long as you stay with Open Telemetry standard, you should be really good right now, and your cost should be rather low. If you want to switch this for some commercial locked-in solution that is not based on the Open Telemetry standard, I don't know. I haven't done that, and it's hard to judge for me how much effort this can be. Thank you very much.
Monica,